Hi, I'm Shadow of Shadow Gaming, bringing you episode 2 of Programming with Shadow. In this lesson, we're going to be looking at variables in C Sharp, data types, what type of data you can store, and user input. So just continuing from last time, we set up our device here, we installed some basic programs we need, and we tested those basic programs. And we tested them with a little small C Sharp program. This time we're gonna build on that information and try to reinforce that a little bit. So the first topic we're going to look at today is variables. So you can think of variable as a container for some kind of data. So in the last lesson we talked about how all computers know about are ones and zeros, and to us it's not really all that valuable. So C Sharp looks at it at a higher level and gives you variables, which is a container for that data. You can think of it like in math class, a variable holds a number. Similar to that, you can treat that number as different things though, depending on what you want to do. So let's open VS Code like before. I'm going to type VS Code. I'm going to pull up a program here I've already written for us. Yeah. But we're not going to worry about the program. We're going to look at the output. Do clear. Close this. So in C Sharp, there's several types of data types. In addition, you can also create your own. We'll learn about that later in the course. For now, we're just going to work with the built-in types. So run this. I guess we're also not going to work with all the built-in types as well. So here's just some of the starting ones, and you may or may not see these. We'll see as we go on. But as you can see, there's quite a few just to begin with. So you can find the link here. I'll try to post that in the video description. So this is where you can find a lot of the built-in ones. These are the ones that I'm looking at. There's others on this list, but these are the ones for now. So of these, I've got them, and this maybe you should say string type instead of character type. But I've got 5 categories here. The first one, Boolean types. So if you had any, or maybe a discrete mathematics or something, Boolean is 1 or 0, true or false, and it's a way to build up basic logic. So in C Sharp, it has a Boolean type, and we'll see that quite a bit in next lesson actually. But for now, you can think of it as 1 or 2 values. You can have either true or false. You'll see when you actually do them, you can actually see it here under the edge just a little bit, but they're actually lowercase. I don't know why they show up as case there, but you use that to tell the computer if something, like, say you have a condition like if this variable is greater than 7. So say you have a variable and it has 5 in it. Is variable greater than 7? Answer is a Boolean false. It is not greater. I put the sizes here as well. We won't worry about that for now. That'll be something maybe in projects, or maybe if I'm building something we'll look at later. But as you can see, everything 1 byte, 2 bytes, 4 bytes. There's a 16. So a byte's 8 bits. So a bit is the 1 or 0 we talked about before. So 1 byte, 16 or 8 bits, 16 bits, 64 bits, 128 bits. So the reason the reason you could think about using smaller size things is they take up less space, so it need less memory or less storage, whatever, what have you. We'll look at that, like I said, maybe in some projects, but for the most part, we'll be sticking with some basic ones for now, like int and double will be the 2 most common. So let's look at the next group, signed integer types, and right below there's unsigned, and if you look, you can see the difference. So signed is just a way of, in computer science, that you say a signed integer can have negative or positive values. Unsigned integer starts at 0 and goes up. Because of that, you'll notice that the unsigned are always bigger. And what it's doing is it's taking whatever this side is and it's being added onto this side. So a byte has a range of 0 to 255, while a signed byte has half that, so half on each side. And one thing you'll notice is the negative is always a little bigger. That's because of how they're stored in memory. We'll look at that. We might look at that later. It's actually pretty interesting, but for now, we just need to know the ranges. So to figure out the size, all you would have to do is do 2 raised to the power of whatever number this is. So this 1 here, you would multiply this by 8. So 2 raised to the power of 8. That gives you 256, which if you count 255 and then add the 0, you get 256. Same thing if you add these two numbers together and ignore the minus. Add the absolute values of them, I guess. So that's how you can get the size and how big the range is, and each one of these does that. You can see a lot, most numbers you're going to need fit into one of these first 3. And we might look into the other ones later, but most stuff will fit nicely into either one of these. Because this is 2 billion or 2,147,000,000, so it's then 400,000. That's a lot of range though, and that's enough for a lot of things. So temperature, we're going to hope temperature, say we're taking temperature, we're going to hope it wouldn't be out of that range, for example. There may be cases that it is, but usually you would have some idea when you're making the program and that you need something bigger. And there's ways to do bigger than this, but they take special handling. So we'll consider whatever the biggest size here is the largest we're going to work with for now. So that's signed and unsigned integer types. We'll look, they'll make more sense. I guess I should have mentioned integer. So integer is just whole numbers basically. So anything negative or positive is an integer. So I probably should have started with that, but I did not. The second type's floating point. The floating point's anything with a decimal point. That's really the easiest way to consider it. The range here, it's you try to do the same math up here as you did with integers. This won't work out, and that's because floating points are stored differently. Let's see. I didn't copy this down before, but I should have. So floating points are stored as a let's write it in. Floating point stored as IEEE. That's the standards organization in computer science, and you'll see it on different things. So floating point's defined as an IEEE 754. That's the standard. That tells you how they do this calculation. Again, it's a little complex for starting out, but we might look at that in the future because it's actually pretty interesting and it makes some numbers make more sense. With all the floating points, I have these ranges here. There's also 3 special values. You can have NaN, which stands for not a number. So that means it's just not a number, so it doesn't fit into any of these numbers. You also have positive and negative infinity. So negative infinity would be anything lower than this, positive anything greater than that. You can see these are big numbers. This is scientific notation, so this is how it'll show up. So this is whatever that is, whatever these numbers are, times 10 to the 308th power. So these are great big numbers, and most things will fit into that. If you look at sizes of things, the number, or like if you count the number of atoms in the universe, it'll fit into this easily. So that's usually enough to handle most data. One interesting thing is that this number is smaller than this one, despite this one being 16 bits versus this one being 8 bits. So this one works a little bit differently, and you'll see it used more with money. So maybe if you have like if we do some kind of bank application, something like that as an example, you might see it more there. What's really happening though is this one's a little more precise, so we'll play around with it eventually, but that's the big difference, is more precision. So these, if you give these a 1, let's say you store a value in this of 1 divided by 3, you're going to get 0.33333 repeating, so 3 is forever. Eventually that cuts off, and in this case I think it's 15 decimal places, so at 15 it cuts off, and we'll round, well, won't round, it'll be 3, but this one here will be 3 as well, so maybe that's not the good one. Maybe 2 divided by 3, so you have 6 repeating. This one will eventually become 6, 7. I think this one should be 6 sixes all the way. And what it's doing, it's keeping better precision for you. We can test that to make sure, but I think that's the behavior I'm expecting. So this last one here is character types or string types. String maybe be the better name. Maybe separating these into their own group would be even better. So a character type just is letters. So in reality, computers, as I said, everything's a number to the computer. So you'll occasionally have fun things you can do and turn them into numbers and do some math on them, and it can be really nice occasionally. But for the most part, characters are the letters you're going to use. There's a 256. It says 2 bytes. Maybe there's more than I'm thinking. I guess it is, because it would be Unicode. So here, when you store information in the computer, you have to have some kind of encoding scheme to handle all the ones and zeros. Unicode or ASCII are 2 of the common ones. We might look into them eventually as well. String here's a little bit of a special case. All these others are considered they're value types. String isn't. So string doesn't have a predefined size, so it depends on what we give it. So each one of these here, if you have in the code, if you have a quotation mark, it's probably indicating a string. That's what exactly all of these are. So each one of these would have their own length if I'd save them out into a variable. I did not, but if I did, we could see that there. So string is special, but we'll use it some as if it's, we'll treat it here at the first as if it's just a variable type for now. It does have some special handling. So let's see what happens with decimal here. We'll just play around with it because I actually don't know right offhand. So to declare a variable, you'll give the type. In this case, I'm saying a decimal, and you can tell it knows it's a reserved word. Decimal. Let's add some space. So decimal, and let's give it a type. So type name. So I don't have a good name, so decimal for now equals 0m. So if you just give it the 0 here, it's going to treat it as a, well, since I've got decimal, I guess it treats it as a decimal. If you just have a 0 just plain in the program somewhere, like, if I add a 0 somewhere, it'll treat it as an integer. If you add a decimal place, it becomes a double. But anything else, you have to give it some kind of character sequence. In this case, you would have to go look up to learn them, but we'll see them eventually. A lot of them make sense, like float is float. Shorts, long's L. Short may not be one. Yeah, I'll have to look up any more. The ones I've used before are L, stand for long, float, and then M. So M stands for decimal. D was already taken. D is double. You don't have to do that though, because like I said, you can just add a 0 like that and it'll be the same thing. Let's say that. So we have 2m divided by 3m. I'll add spaces around that. Let's see what this does. So let's do a console.write. Put my decimal in here. So if we remember from last time, consoles, basically you can think of it as called a method. You might call it function here, but it's technically a method. Well, this one's the method. This is what the method's, where the method's at. So We have the console here, and it has the method write line. What that lets us do is write text out here to our terminal. You can see I've already got all this up here, so expect it to also show up. But at the end, we should just have a number show up. Let's see what that holds. .NET Run. Uh-oh, I have a problem. What is my problem? Line 20. Did I miss it? I did. So what I missed here was a semicolon. Now we've seen in a compile issue. So this is saying error at this line. So program.cs, that's the name of the file. Line 20. Then it was at character 41. Hiding behind my microphone, but if I look over there, I can see the 41. Sorry, I'm hoping I'm recording. I've lost my recording software. Hopefully it's still there. Yes, okay, sorry. Sorry, everything froze up just a moment there. So I was talking about error. So we got a program here, and it said here on line 20 and at character 41, so it said I was missing a semicolon. So fix that. I just added the semicolon. Error CS102 semicolon expected. So that easy fix. Let's run that again and see what happens. Look, it did. It does round eventually. It has a lot more numbers there. Maybe that's all I'm thinking of. So if I wanted to, I could look here at this. It probably says in here. So if I go up to decimal, we look here. Yeah, here. So it has 28 to 29 digits of precision versus 15 to 17. So yeah, so that's the difference. Okay. As you can tell by that, you probably won't run into that all that often. So it depends on what you're working on. But I guess where I'm at, I do more scientific, so I see more double than decimals. And maybe if you were working in a bank, maybe you'll see otherwise. One thing I noticed, this opened an edge. I thought we fixed that last time, so let's fix that today. So as an aside, let's go to settings. Go to default apps. I don't think this is where I wanted. Here we go. So let's set this to Firefox. This to Firefox. I think that'll do. So now if I click a link over here, this should open up in Firefox instead of Edge. Opened in Edge again. Did not save that. There we go. Try that one more time. There we go. Okay. I should go in there, and while I'm doing that, default apps again. Set text. Now it's opening in Notepad. It doesn't show up here, so we added Notepad++, so I'm going to come here, and this is in C, Program Files. I'm going to go to Notepad and pick notepad.exe. Set as default. Okay, so there. I thought I did that last time, but I guess I forgot to finish that. All right. So here's data types though, and like I said, I'll post this link for that file pulled up there. I'll post that in the video description, so there you can go through and see all the information. And if you looked there when I had that pulled up there for the moment, you'll see there's some in here I didn't talk about, like native int, inint, nuint. Well, we might look at them eventually. For now, I'm going to stick with the others as the basic ones we need. Basically, those are ones that have came about, but I actually haven't seen used yet. So maybe they'll be more popular in the future. All right, let's go ahead and close this folder. The file, close folder. Let's do a program. So if we remember from last time, we can come up here and go to terminal and open a new terminal. So here it opens in my user directory. I created a source directory in here. If I do ls, I can see it in here. I have a source, so I'm going to do cd, which stands for change directory, source, then enter. Now I'm going to do ls again. Now we see we have that data type example I just looked at in our original hello world. Make a new directory. So to do that, I do mkdir. Let's call this one, let's call it hourly wage. Now, I've created that, so now there's a third one in here. And then I'm going to do cd hourly wage. Now we're in here. So it's going to be empty. I can show that. Now let's run .NET. Thinks I want run. I actually want new console. So here we're going to take that name hourly wage and we're going to create a program for it. Now if I do ls, now we have our object directory, our hourly wage CS project, and program.cs. So programs.cs, that's the common starting name. You can change that if you want. I believe it'll still work. Test it to actually make sure. So to rename something in terminal, you use move. So move program.cs to, let's call it hourly wage.cs. Notice I changed the casing here. I used uppercase here instead of dash. Let's do that. So now if I look, now I have that file. Let's do something now. So I could come up here and open in folder, and that would work. What I can instead do is do code dot. Now we open the new one. Look, we're already there. So over here, I'm just going to close the old one. Maximize this. And let's see if this actually works. I think it will. I'm going to click, don't show this again for this. We'll just ignore that one because we'll actually want that one eventually, but I want to control when I get it. I don't want to just start with it right at the moment. It makes it too easy to find them easy typos, and that makes it easy to show a bug or show a problem. Let's talk about what I'm wanting here. So we're wanting to play around with variables a little bit. So what we're going to write is a program to do something. In this case, we're just going to keep it simple. So we're going to start with a program, and we're going to have an hourly wage, or have an hourly pay and an hours worked, and we're going to multiply them together and output a hourly, or how much you made, basically. Your pay, I guess. Let's do that. Let's start with a new variable. Let's do, I'm going to start with int here, but we might want to change this to double. It probably makes more sense as a double. Let's do int. Move my cursor. So int. So start with a variable, you start with the name, do hours worked. So this will work here, and we can also do int hourly pay. That will work, and then we would come down here and do hourly hours worked equals 40, hourly pay equals 10. Make it an easy calculation. That'll be 400. So now we can do that console right line. So here we seen that earlier. We can do different things here. So let's start with this. So I'm going to put a $sign here in front of my quotes. Let's do I'm just going to keep it simple. Work for hours worked. So if we remember from last time, putting the curly braces in the center like that lets you put in the variable like this. So hours worked, so I put the variable there, and it'll turn that 40 into the numbers we see, the string we see if we remember the variables that we mentioned before. Hours worked, for 40, it worked for however many hours at a rate of angle bracket or squirrely braces, hourly pay for a total of total. So we're going to add a new variable called total. So sometimes you'll see people only start way up here at the top. That can be fine as well. Let's start with an int as well. We know I'm going to want double here in just a second for my example, but we'll start with int. So right here, these are all separated. You can also just declare these in line. So I can do total equals hours worked times. So for times, we use an asterisk here. That's the character beside the 8 on your keyboard. So hours worked times hourly pay. Now we have total. So there's going to be some problems here, but I think this is actually going to be pretty close here at the first. I'm going to open my terminal. You can come up here and click terminal if you'd like. You can also press control and then the grave or the backtick, the little character beside the 1 on your keyboard. Now we can do a .NET run and see if I made any typos. So I actually already see one, so let's go ahead and fix that. I'm about to forget the semicolon again. Let's try this now though. Look, it worked. It worked for 40 hours at a rate of 10 for a total of 400. Be nice. So to be nice, let's adjust this. So hours make sense. We should add a $sign here. I'm in the US, so I'm going to use dollars. We should add one here. This will be a little nicer to read. Also add a period at the end, maybe. There we go. A little nicer to read. So that'll work for basics. So let's say we don't make a even amount though. So let's say we worked 37 hours. 47. Let's say the rate instead of this is 1157. A good not round number. So what's going to happen here? If I try to compile this, it's going to say this one's fine. The hourly pay isn't. So hourly pay here is a floating point number. So that's what the decimal means. So it's not an integer. So when we try to fit it into an integer, we're going to get an error, and it's going to tell us that. You can implicitly convert type double to an int. So it's saying this is a double. So a floating point number here is a double. We can't convert that to an int. Let's fix that. So let's make hourly pay double. So hours worked should probably be a double as well. Now there's another problem. So when we multiply two doubles together, it's going to be, we're trying to shove it into an integer. So integer already can't take the double, so the decimal place. These are also both larger than an integer, so it wouldn't fit anyway. So we also need to make double here. That's a thought of something you can see. What happens if you have values that are too big, and that's called an overflow. And there's ways you can deal with that. I'll probably look at that eventually, but for now we're just going to assume that this is going to be fine. We'll look at that probably next lesson, actually. There we go. That actually doesn't look terrible. So one thing we can do though, let's make it even less. Set a 1. Does that rate make sense? Probably not. Let's not do that actually. Yeah, let's do it up here. Let's make this, we did 47 and 11 hours. whatever an 1100th of an hour is. It doesn't matter. We're just trying to see the number not look nice here. There we go. Now suddenly that doesn't look nice. If we do the math there, we might see that that doesn't actually end up correct. So we could do that if we'd like. That's where that IEEE, what was it, 557? 754. IEEE 754 comes in. It tells you all about how that's going to show up. And in this case, that doesn't look very right for a total on money. So right now, I hard-coded these dollar signs in. So there's a way, so this is common enough in C# that there's a way to format these variables, format how they appear. So the way to do that here is to do a colon, and you give it some kind of control characters here. My control character is going to be a capital C and a 2. So we could do a C3 or a C2 or whatever. I'm going to do that same thing over here. I'm going to do C. Let's try 4. I actually don't know if this works, so I just want to see if it works. So I think that'll say make it a currency with 4 decimal places, and it did. So 3, and 3 I think will round it for us. But 2 is where we really want, so that'll be the last stage. So yeah, so 3 rounds up, so 4 would have rounded if this wasn't a 0 here. So there, it's a little nicer, and one problem, I forgot to delete the dollar sign, so now we have double dollars, so let's get rid of that. But now we got a little bit of a program here. So there were some problems here, though. Every time I wanted to run this, I have to come in here, and I would have to change this. That's all right here while I'm looking at it, but say I just gave this program off to someone else, and they don't have the code anymore. So we could see that situation here. If I come into this bin here, there's this hourly.exe. Let's just copy this, drop it here on the desktop. See if this works. It may not work. Sometimes you have to actually publish something before it'll really show up correctly. Not copy. Tell you what, I know how to copy it. Let's do CP, which stands for copy. Copy bin debug net 80 hourly wage.exe. There we go. I'm just going to copy it to tilde, which gives me my home directory. That added me .NET. I don't want that. And desktop. There's the terminal way to copy a file. There we go. Now if I go back over here, we have hourly wage.exe there. So I could run it from here. Let's click this little plus here. This will open us a new terminal. So now there's 2 over here. This is their original. This is the new one. So it's in the wrong place. So let's go back. cd ... As we mentioned yesterday, or in the last lesson, ... will let you go back a layer. If I add, so that brings me the source, but I know I need to go back one more by my prompt here. So I'm going to go back 2 levels. And now we're here. And look at there. If I do ls, there's desktop. So now we can do cd desktop. Now if I do ls again, now we see what's there on the desktop, including hourly wage. Let's see if that works. There we go. Froze up just a second. If I run hourly wage, the application doesn't exist. So it does not have everything, so that won't work. So if I did actually publish that though, and I got all of their information together, you wouldn't have the code at that point. Let's do, I'm just going to go over here. Since this doesn't work, we'll delete. We'll worry about that in a much later video. So for now, we'll just assume that that's the case. So if we don't have the code, how would we change it? We'd have to tell whoever has the code to go change it. And there's got to be a better way. So that better way is to allow the user to input data. Let's look at that. So I'm going to delete these 2 here, but I'm going to leave the variables up there. we'll want them in a moment. I'm going to leave everything else the same for now. Let's do a new variable. We're going to call it a string again. I'm just going to say string user input. So where I'm capitalizing the letters here, that's to make these more readable. So there's various things you could do. You could do that, and that's, as far as the computer's concerned, it's perfectly fine with that. That can get hard to read though, especially if these are longer. The one strategy that people's come up with is called camel case. That's what this is. So start with a lowercase, and then you make whatever the next word is uppercase. There's also this case. This is called Pascal case, and you'll see that in C# as well, like down here on right line. But those are used in different contexts, and if you stick with what C# recommends, everyone's sort of using the same thing, and it makes it easier to understand and work through what you're doing. So that's called camel case, and that's what I'm going to use for variables. So let's do this. I'm going to do user input equals. So we're going to use that console again. Dot. So we've used write line. So another thing we can do is read line. The read line just takes whatever you type in here in the terminal, and it'll write it up here, and store it for us. In this case, store it as user input. And when I compile this, I'm going to get a warning, and I'm going to ignore that warning for now. Basically telling me that this isn't guaranteed to give me a string. It can also give me another type called a null. And basically that just stands for no value. We're going to ignore that for now, and we'll worry about error handling later. For now, we're just going to look at reading the user input. There we've got the user input. It's a string though. So how does that work? So as a string, it's just text, and that text is a number, and the computer can understand it because it knows it's a string. But if we try to make it into the hours worked, let's say hours worked here, make the other one, let's make the default pay like $10. Say it 10. Let's say default hours worked. Let's not do that. Do hours worked equals user input. So when I compile this, .NET Run, it's going to, we're going to get an error. Error cannot implicitly convert string to double. It's saying it can't do that. So how do we read this? C# provides us methods to do that. So in this case, you tell it what you want. So I want to double, and then it has a parse method. So parse is the computer way of saying, here's a number, or here's a string, and I want to get a decimal out, or a double out of this. Decimal, double, integer, whatever type you put over here. I want to get this out of whatever I put in here. So parse user input, and turn it into a double. So now, if we run this, we should see whatever I type in here. I'll run .NET, run. So here, there's my warning. Like I said, we'll worry about them later. But here's a warning, and it seems to be frozen up. So what's happened? So read line here is what it's asking the user for input. In this case, I haven't given it any input yet, so it doesn't know it's waiting. So say we worked, let's say we worked 25.5 hours. So there we go. We worked 25.5 hours. So there we go. It took the number, parsed it, turned it into a double internally, used that for the value here, and added it. Let's do that for the hourly pay as well. So now, what would happen here is it's going to take that same value, and whatever we put there, it's going to show up twice. So that's not exactly what we want. So we need to do this step again. We need to do user input console read line. Put those together. Then I'm going to put them here again. So you can reuse variables, by the way. We haven't actually seen that yet. I guess I was showing it right here, but So I've created user input up here, and now I've used it at two separate places. And I've reassigned its value. That's perfectly fine in C#. What you can do, if you don't want that to be the case, you can do const. So that stands for constant. It says hourly pay is always $10. In that case, I'm going to get an error here because I try to make it not constant. So we'll look at that in the future for sure. But for now, we want variables to be variable. We want them to change. So also get rid of this 10. We no longer need it. Now, when we come down here and run our program, it's going to freeze up again. We get more warnings again. We'll worry about them later. So here it's froze up. What it's asking for is user input here. So hours worked, let's say 40. We made $25 an hour. $1,000. Okay. That worked. It'd be a little hard to read. It would be nicer if we could tell the user what's happening there. We can do that. So here, before we do the console.read lines, we're going to do a console.write line. Let's say enter hours worked. Down here, let's do console.write line, enter hourly pay, semicolon, semicolon. Now, let's see what this looks like. So this is going to be close to what I want. So now hours worked. So we worked 32 hours and $10 an hour. Okay, we can do better than that though. So another method here is we can get rid of line here and we can just do write. Do you notice I left a space here after my colon? That's because I want to add the text at the end there. I want to add whatever I type here instead of enter hours worked and then new line 32. I want the 32 to be over here. We can do that down here too, and we can do one more thing to make this one a little nicer. We can add a $sign. That way it'll show a $sign before whatever pay we enter. Now, if I run this now, I need to change this to write. If we run this now, this is exactly what I'm imagining. So hours worked. Let's say we worked 10 hours. We made $15.98 an hour. And there, we have a very simple program. There's some problems here. As I said, next lesson we might start looking into handling some errors here. We might start with this program again and actually work to clean it up. So right now, say I'd come in here and run it again. Say I'd make a typo and press and enter an A here for hours worked. A was not in the correct format. So that's what. So here on that parse, this is what happens here if it parses and it can't understand it. So there's better ways to do it. Still got a little bit of time, so let's do a beforehand preview. What we can do here, we could say, I'll comment this out. So in C#, a comment is the way to say, hey compiler, whatever's after these two symbols, don't worry about it. It's a comment. It's for users to read, not for the compiler to read. So now let's do double dot try parse. So now we're going to put in user input here, and we're going to do out hours worked. I'm just going to do it here just for the sake of example. We'll learn more about what this is doing next time. So it's going to try to do this, and if it doesn't work, in this case it's going to go right on. So I guess I can't show this without showing you the new feature. So go ahead and show the next feature. So if next time what we're going to learn is how computers make decisions. So we have some kind of data and we make some kind of decision out of it. That's going to be this if here. Here, we can say if this, and we're going to put an exclamation point. Exclamation point says not. So if the try parse does not work, what do? We're going to do console write line. This is hours worked. Put a $sign here in front. Hours worked. I'm going to put the hours here. No, that's not right. User input. Was not a number. Then I'm going to do system.exit. So system.exit, that's something you haven't seen before. Thinking about it, it might be environment.exit. I'm about to figure out if this is even right. It might be environment.exit actually. But it's going to tell the program when it hits this case, quit. Let's see. If this isn't it, I'm actually or I didn't plan for this, so what's the extra? Yeah, there we go. So it's environment. So I'm going to enter a here. Hours worked was not a number. To make that a little easier to tell, I'm going to put quotes around it. Single quotes. Hours worked A was not a number. That's a little bit of the future. What we're going to see is error handling. So let's undo that though. Like I said, that'll be for next. I'm going to press a keyboard shortcut here. I'm going to press Control K, Control C. So that stands for makes it do an automatic comment for us. Then I'm going to come back over here, Control C again. Wait, no. Control K. Okay, Control K, Control U, and undo a comment. There, we're back in the original state, although we do have a comment. So let's make one more change, and we'll say this is about it for the day. So right here, I separated these up here. You'll see that a lot of times when you're starting, and what that's trying to help you with is to make sure you understand what you're doing. So what we're saying here is create a variable, the hours worked, that'll hold a floating point number. Create a variable hourly pay that'll hold a floating point number. And create user input, a variable that will hold a string. And then down here we assign them some values. So user input gets this console.readline, so whatever we read from the console. Hours worked gets double.parse, so whatever user input is, we try to interpret that, parse that as a double, and hours worked gets that value. That's sort of how you would read through what this is, and sometimes you'll see it like that. Sometimes you might see it like this instead, like user input here, and this line not even here. And depends on who wrote it, how you did it. As far as which one matters, there's not a lot matters. Like this will be perfectly fine. I'm going to favor leaving it like this for now and reading through the program like that. But in time, I'll switch to the other style. Let's continue reading through just real quick. So then here, the console.write, we'll write this to the console. Then read in from the console, and user input gets whatever we read in. Now hourly pay gets whatever we just read in, and we parse it and try to turn it into a floating point double. And then we create a new variable. So notice that one's not even declared up here, and it's declared right here. So what I could do there is I could also just do this. This would be perfectly fine as well. And like I said, I'm probably going to prefer that just for the start here. I'm going to say total gets hours worked times hourly pay. And then we print a new line to the console of this information here. So that's how you would read through this little program we've written. We also have a comment here in the middle. Like I said, we'll look into that more next time. So let's see. Anything else I want to cover real quick? Oh, one last thing. So right now I declared these on different lines. You can also do this. So let's delete all of this and put a comma here. And a comma here. So this will be valid as well if I didn't mess up the syntax, but I believe that's right. So this will be valid, and yeah, hours worked 40 at $15 an hour. $100. So you can also declare multiple like that. You'll, again, if you're reading or a textbook or something, you'll see that a little bit too. I actually very seldom actually see that in real programs. Most of the programs we write would do like here, like we would just do string here, double here. This one doesn't need a string again because it was declared before, so you don't have to redeclare something if you haven't used it before. If you haven't used it though, you have to say what it is. Now I think this will compile for us. Yep. 50 hours at $18 an hour. So that works. So depends on what style you like here at the beginning. For next time, I'm going to leave us in this state. Control U, Control K, Control U. I'm just going to leave us here for next time, and we'll pick up from this next time. So in this lesson, what we've looked very briefly at data types. We've looked at sort of what will fit into different data types and very lightly how to use them. We'll look into that more as the further we go. We also looked at variables. We've talked about how to declare them, special ways to declare them like this, like putting them all in one line, putting them on the same line. There's not a lot of reason to care about that except just reading your program here when you're starting. Sometimes it's actually easier to understand if you've got them up here at the top. You can read through it and think why you're using them. Sometimes you'll even comment why. I think if you use good names, you probably don't need that comment. Like hours worked here was perfectly fine, and that's what you're going to store in there. And maybe that's not what you store in there. Maybe you do something else, and at that point your name's wrong. And at that point, maybe you need a comment, but maybe you also should fix the name. So there's concerns like that. The third thing we really looked at that was completely new was these two lines. So here we read in text from the console, and then we take a string, which is that text we just got from the console, and we interpret it as a double. So parse and read line. That leaves us a bunch of we'll call them system calls for now, but a lot of different things we can do. We can read lines from console. We can write lines out to the console. We can take a string and we can parse it. You see here, we're going to learn a more advanced parsing thing we can do next time. So that's going to do it for now. Next time we'll look at conditions. So making programs do something, making them make a decision. And for that, it's going to be this if-then structure. That's going to be about all the time we got for now, though. So we'll go ahead and cut the video here and see you next time. Thanks for watching and have a wonderful day. Beto out.